In lesson 8.7, we're going to be solving and working with exponential and logarithmic equations. And what we're going to do is we're going to think through, we've talked through some equations already that are a little easier to solve, like if we had 2 to the x equals 8, well, we know 8 is 2 cubed, so therefore x has to equal 3. But here we have 3 to the x equals 32. It can't be solved easily like that because 32 can't be written as a power of 3. And so what we do is we're going to change things into log form. Log base 3 of 32 equals x. That can help us get an exact answer. So one really important thing here is what is called the change of base formula. The nice thing about the change of base formula is you can take log of any base that you're given or that you start with and change it to a base that you want. And what we'll be doing is we'll be changing things to log base 10 because that's common log. So log base 10, which remember we don't even have to write that base. Also later on we'll be using what's called natural log, where we have this what's called the natural number e, log base e of something, which shorthand for that is natural log. Actually, we shouldn't write it like that. We should say log base e of some number x is just the same thing as ln of x. So we can convert bases that we're not as familiar with or that are not on the calculator into ones that are on the calculator. And so this is the change of base formula. What you can notice here is you have log base b of a equals the log, and usually we'll use base 10, log of a over the log of b. And so we'll be using that change of base formula throughout. So this one right here, this is from a couple slides ago, we can change this to log form. So we have log base 3 of 32 is equal to x. Well, we're not as familiar with log base 3, but we can use this change of base formula, which says we can take common log of 32 over the log of 3. And then what you can do is you can put that in your calculator. You find the log button. You do log of 32 on your calculators. Make sure you put parentheses as necessary. So log of 32, end your parentheses, divided by log of 3, and you get about 3.1547. So which we can think back, this kind of makes sense. We know, or it does make sense, 3 cubed equals 27. So this is saying that 3 to about 3.1547 is going to equal 32. And so x is equal to, whoop, bad circle, but x is equal to 3.1547. Continuing on, here's another way we could do this. And we're going to introduce an idea to you. We still have 3 to the x equals 32. And we'll use this method later on, but what we can actually do is we can take the log of both sides, just like we can divide both sides by the same number or multiply both sides by the same number. We could actually take the log of both sides and so I'll actually rewrite this so we have log, so we took the common log, there's a base 10 of 3, and we remember this, now that we took the log of both sides, this x can come out here, equals the log of 32. And log of 3 is just a number, it's a constant, so we can divide both sides by log of 3. So divide both sides by log of 3, And actually we saw this expression earlier in the other method when we just did the change of base formula, log of 32 over the log of 3. And so we still get, obviously it should be the same thing, x equals 3.1547. So there's another method where we take the log of both sides, and sometimes that method is going to be helpful for solving equations. And here is one of those ones that we could do that. What we can do here is we can take the log of both sides. Now we write log on the left side. We don't put it over here because we're taking log of 12. And so now, again, this x plus 5 can come out. We make sure we put parentheses around it because this is multiplied by the log of 4. So here we used the power rule, where this x plus 5 comes out in front, equals the log of 12. We want to solve for x. Well, we need to distribute this log in here. Well, there's a couple different ways we could think through this. We could actually just divide both sides by log of 4 and then subtract 5 from both sides, or you could distribute, but either way it works out. So we will divide both sides by log of 4. Now, anytime along here we could plug log of 12 in our calculator or log of 4 in our calculator and get a decimal approximation. I definitely prefer to leave it in terms of logarithm till the end, because then you can just type it in once and don't have to worry about those decimals throughout. So log of 12 over log of 4, and then we would subtract 5 from both sides. And so we get x equals log of 12 divided by the log of 4 minus 5. Again, you can put that in your calculator. Do log of 12 divided by the log of 4, and then take that answer and subtract 5, and you will get negative 3.2075. And that's your answer. Now realize that means we can put this number back in. We know that if we had 4 to the first is 4, 4 squared is 16, so we need whatever this x plus 5 ends up being to be between 1 and 2. And if we put that negative 3.2 in there, it will make it there. So it's just a mental check to make sure the answer makes sense. Here's a word problem and then a formula that we can use to help us. So this is carbon-14 has a half-life of about 5,730 years. A piece of wood contains 19 grams of carbon-14. Predict when there will be 8 grams of carbon-14. And so here is, really it's an exponential decay equation. This is your future amount. F of t stands for the future amount after a certain amount of time. A stands for the original amount. We have a 1/2. T stands for time in years, and this capital H stands for the half-life. So what we can do is we can plug the information in that we know. We know a piece of wood has 19 grams, and so we can put 19 in for our original amount. Predict when it will be 18, so that's our future amount, and we want to know at what time, how many years will go by for that to happen. And we have 1/2 t, that's what we don't know, over the half-life, which was this 5,730 years. Well, this is an interesting problem to solve. One thing I want you to be aware of, this mistake is often made. This says 19 times 1/2 to the t over 5,730 power. We cannot multiply 19 by 1/2 because exponents come first in the order of operations. So what we need to do here is we need to divide both sides by 19 to start working our way to getting t by itself. That's supposed to be divided by. And so we have 18/19 is equal to 1/2 to the t over 5,730. Well, as in some of the examples before, we have a variable in our exponent. So what we can do is we can take the log of both sides. So let's write that in here. We're going to end up taking the log of both sides and the log of this side. And that will give us, we'll go ahead and start up here. We have the log of 18/19 equals, and the reason that we take the log of both sides is we can use this power rule. So this fraction will come out front. So we have t over 5,730. So that exponent comes out front times the log of 1/2. And now we want to solve for t. Well, we can work our way through this. Let's divide by the log of 1/2. We're going to have something that looks like a compound fraction here, but that's okay because we can just type it in our calculator when we get to our answer. So divide by log of 1/2. And this would cancel with this. And now looking at that, I'm not going to write a second line. I'm just going to realize, well, I have t divided by 5,730. Well, I'm going to go ahead and multiply both sides by 5,730. And so we get this answer that t over here equals, now this is like an over 1, so we can put that in the numerator. So we have 5,730 times the log of 18/19 over the log of 1/2. And after you carefully put that in your calculator, so 5,730, just hit the times sign, log of 18 over 19, close the parentheses, then hit divided by log of 1/2, and you can even just do 0.5, close the parentheses, and then you can hit enter, and it will give you that t is approximately equal to 447 years. And there's your answer. So we had an equation or a formula that deals with a variable in the exponent, and so therefore we were able to use logarithms to help us solve that.